Hello everyone. In this video we are going to learn theory of co-prime numbers, which are also called as relatively prime numbers, and Euler's totient function. So let's start. So first of all, co-prime numbers. Co-prime numbers are also called as relatively prime numbers. The definition is A and B, these two numbers are co-prime if one is the only common factor. If one is the only common factor between them. And the other definition is A and B, these two numbers are co-prime if the HCF, the highest common factor HCF of A comma B is equal to 1. Then A and B are called as co-prime numbers. Now let's have a look at the examples. So few random examples are, look here, 9 comma 16, then 16 comma 49, then 33 comma 25, then 35 comma 33, or you can say 35 comma 39 as of now. Now few other examples, let's have a look at it. 9 8 comma 9, then 15 comma 16, then 25 comma 26, then 35 comma 36. So from this what we can say that any two consecutive natural numbers, any two consecutive natural numbers are co-prime. After that, few more examples, let's have a look at it. First is 25 comma 27, then 33 comma 35, then you can say 49 comma 51. So from this we can say that any two consecutive odd numbers, any two consecutive odd numbers are co-prime. After that, let's have a look at few examples which are not co-prime pairs. For example, 33 comma 48 is not co-prime because 3 is a common factor in between them. After that, 35 comma 63 is not a co-prime because 7 is a common factor in between them. So now let's have a look at questions which are related with co-prime numbers. The first question is how many natural numbers which are below 40 and co-prime with 40. So there is a direct formula to find this, but before that let's do this question manually. So over here we are talking about number 40. We need to list all the natural numbers which are below 40, that is 1 to 39, and which are co-prime to 40. So let's identify manually. 1 comma 40 is co-prime, 2 comma 40 no, 3 comma 40 yes, 4 comma 40 no, 5 comma 40 no, 6 comma 40 no, likewise 7 is a co-prime, 8 no, 9 yes, 10 no, 11 yes, 12 no, 13 yes, 14 no, 15 no, 16 no, 17, 18 no, then 19. After that, 21 and 40 co-prime, 22 no, 23 and 40 co-prime, 24 no, 25, 26 no, 27 and 40 are co-prime, 28 no, 29 and 40 co-prime, then 30 no, 31, 32 no, 33 yes, 34 no, 35, 36 no, then 37, 38 no, 39. Okay, so these are the numbers which are below 40 and co-prime with 40. And what is the count? Count is 8 and 8, total these are 16 numbers. So how many numbers which are below 40 and co-prime with 40? These are the 16 numbers which are below 40 and co-prime with 40. Now there is a direct formula we'll show you later on. As of now, let's have a look at two more questions which are dependent on this calculation. Let's have a look at those two questions. The first question is, in how many ways 40 can be expressed as sum of two relatively prime numbers? Now if you observe these 16 numbers, The addition of every pair is 40. The addition of every pair is 40. So what we can conclude is, out of these 16 numbers, take any number. For that particular number, there is some another number such that their addition is number itself. And this is going to happen for each and every number, not for only 40. This is going to happen for each and every number. So you can see that in how many ways we can express 40 as a sum of two relatively prime numbers. There are 8 such a pairs. Which pairs? 1, 39, 3, 37, 7, 33, and so on. These are total 8 pairs in which we can express a number 40 as a sum of two relatively prime numbers. Now the next question is, find the sum of all natural numbers which are below 40 and co-prime with 40. Means over here we need to find sum of all these 16 numbers. You can see that there are 8 pairs of addition 40. There are 8 pairs of addition 40. So the total addition becomes how much? 320. This is how we can answer this question. Now let's have a look at the formula. For the formula, the problem statement is, look here. The problem statement is, how many natural numbers? How many natural numbers below n are co-prime with n? So this concept is called as Euler of n. This concept is called as Euler's totient function, which we represent by the symbol phi. Phi of n. How to read this? Phi of n, or Euler of n, or totient function of n. So what is the formula of this? But before this, what we need to do is, the pre-requirement is you need to prime factorize number n. So let's say the prime factorization of number n is a to the power p into b to the power q into c to the power r into so on, where a, b, c are prime numbers and all powers p, q, r, they are natural numbers, not whole numbers here. So in that case, the formula to find phi of n is equal to n into 1 minus 1 divided by first prime factor a into 1 minus 1 divided by second prime factor b into 1 minus 1 divided by third prime factor c into so on. For example, the prime factorization of 40 is 2 to the power 3 into 5 to the power 1. So over here the Euler of 40 becomes how much? 40 into 1 minus 1 divided by first prime factor 2, 1 minus 1 divided by second prime factor 5. So this is going to be how much? 40 into 1 minus 1 by 2, 1 by 2, 1 minus 1 by 5, 4 by 5. So this is going to be how much? 16. So from this we can conclude that the Euler of n, that is Euler of 40, is equal to 16. Now after this, let's take one more example. Let's talk about 600. The prime factorization of 600 is going to be 2 to the power 3 into 3 to the power 1 into 5 to the power 1. So let's check, is it correct? 5 to the power 2. This is 25 into 3, it's 75 into 8, it's 600, yes. So in that case, the Euler of 600 is going to be how much? 600 into 1 minus 1 by 2 into 1 minus 1 by 3 into 1 minus 1 by 5. It doesn't matter what is the power. We are concerned only with the prime factors used. So this multiplication is going to be how much? 600 into 1 by 2, 2 by 3, 4 by 5. So this multiplication is equal to hold on, this 2 and 2 gets cancelled out. 5 3s are 15, 4s are 14 to 4, 160. There are 160 numbers which are below 600 and co-prime with 600. Now few quick questions if I ask you. The first question is, in how many ways 600 can be expressed as sum of two co-prime numbers? The answer of this question is, for every number out of these 160 numbers, for every number there is some another number such that their addition is 160. So how many pairs you can make? 160 divided by 2, that is equal to 80 pairs you can make. And the second question is sum of all numbers which are below 600 and co-prime with 600. Sum of all numbers which are below 600 and co-prime with 600. The answer of this question is, there are 80 pairs of the addition 600. So the answer of this question is 48,000. Now after this, there is a one more question. Let's have a look at it. Let's learn that question with the help of 600. Though the prime factorization of 600 is equal to 2 to the power 3 into 3 to the power 1 into 5 to the power 2. The question is, in how many ways 600 can be expressed as product of two co-prime numbers. In how many ways 600 can be expressed as product of two co-prime numbers. So let's have a look at it. So over here, for example, 600 is equal to, can I write 600 as, let's say, 2 square into 3. This is the first number. Into second number is 2 to the power 1 into 5 to the power 2. So is this a co-prime pair or not? A and B, is this a co-prime pair? No, this is not a co-prime pair because 2 is a common factor between both. So which numbers are co-prime pairs? The first number is 2 cube and second number is 3 to the power 1 into 5 square. Yes, this is a co-prime pair. Then 3 to the power 1 is the first number and the second number is 2 cube into 5 square. This is a co-prime pair. Then 5 to the power 2 is the first number and the second number is 2 cube into 3 to the power 1. This is also a co-prime pair. And then the first number is 1 and the second number is 2 cube into 3 to the power 1 into 5 to the power 2. This is also a co-prime pair. So in how many ways we can write 600 as a product of two co-prime pairs? What is the answer of this question? These are the 4 ways. Other than these 4 ways, you will not get any new pair. So what is the formula to find this? Let's have a look at it. The formula to find this is, the problem statement is the number of ways of writing n as a product of two co-prime factors, as a product of two co-prime factors is equal to 2 to the power number of prime factors and minus 1 in the power itself. For example, 600 was having total 3 prime factors, that is 2, 3 and 5. So in case of 600, the answer is 2 to the power number of prime factors are 3, that is 2, 3, 5 minus 1. 2 to the power 3 minus 1, 2 to the power 2, that is equal to 4. There are 4 ways in which we can write 600 as a product of two co-prime factors. Now let me ask you a question. You can answer that question, the answer of that question, in the comment section. The question is, in how many ways 25 factorial can be expressed as product of two co-prime pairs? as a product of two co-prime numbers? Let's try this question and answer in comment section. The question is, in how many ways 25 factorial can be expressed as a product of two co-prime numbers?